This is my beginning algebra course. In the next class, you're going to take the first test of this course, and today we're going to prepare for that test. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. Now, a lot of people would say, wait a second, why are you giving tests? This is not a real course. Well, number one, this is a real course, and number two, the purpose of a test is obviously to figure out if you can actually do the math. You actually have to be able to do these problems, not just watch me do them. Now, when it comes to mathematics, you cannot pass a math exam without studying for the exam. There are some subjects where you can cram for 1 hour the night before and get an A on the test. That's not how math works. If you don't study for a math test, most likely you're going to fail. And I'll tell you, if you haven't done the homework problems I assigned you, and worked with the problems with me in class, then you're definitely going to fail. That's a 100% guarantee you're going to fail. Now, it doesn't matter how many times you tell students that they have to study for exams, they're not going to do it. So what we're going to do today is we're going to do a practice test right now together, and then I'm going to give you a practice test for homework. And there are two reasons for these tests. Number one, they're going to show you what my tests are like. So you can't take test number one and say, well, I didn't know it was going to be like that. You're going to have two tests that you're going to finish, and you're going to know exactly what my tests are going to be like. And the second reason for these tests is to, again, force you to at least do a little bit of studying for the test. Now, these practice tests are not going to guarantee that you get an A on the test, but hopefully they'll at least ensure that you pass the test. If you want to get an A, then you have to go back and study all the class problems that we did. You can take screenshots of all the work that we did in each class at the end of the video. There's a time code in the description section of the videos you can go to. You can look at all your homework. Make sure you know how to do every single problem. In fact, I don't want you to go on to the next class unless you are absolutely sure that you know how to do every problem, because there's just no reason to take a test unless you're prepared for it. But let's go ahead and get started here. As you can see, we have instructions as usual. Write a title, your name, the date, the course. The course title is Beginning Algebra. Number each problem. If you're using this test, if you print out this test, then you don't have to number the problems. They're already numbered. Rectangle your answers. These are all things that you need to do, or else you're going to lose points. Now, as we go through this practice test together, I want you to do every single one of these problems on your own, if you can. If you think you can do number one, for example, I want you to do that on your own. Don't just watch me do it. You're going to absorb this information much more efficiently if you just do the math on your own. Now, if you don't remember how to do each one of these problems in this practice test as we work along here, then you can watch me do the problem. But as soon as you start to feel that you're remembering how to do the problem, stop the video. Stop the video and take over on your own. Again, you want to do as much of this practice test on your own as you can. So that said, let's get started. So it says here to simplify the following polynomial, write in descending order of powers, and state its degree. So we're going to add the fourth terms. Remember that you can add like terms, but you cannot add unlike terms, obviously. So we have apples on apples there. 3 plus -1 is 2. And then we're going to add we're going to take the x cubed term, which there's no other x cubed term, so there's nothing to add it to, so we're just going to put that there. And then we're going to add the x squared terms, that is. We have 2 of those. So you put those together. -6 plus -4 is -10. And then we can add the regular x terms. So -7x, and I guess that's it for those terms. So we have -7x. And then we're going to add the normal numbers. So we have -8x 2 and 7. So then we get 1. And it looks like that's it. So obviously I'm doing a lot of work here with these colors. You don't have to do that, but I'm just we're just kind of reviewing how to do this. So let's go over this and make sure we have everything correct. Everything looks right. And so now we did two things there. We simplified by adding like terms, and we wrote in descending order of powers. So we have fourth power, third power, second power, 1 power, and we call that a 0 power. You don't have to worry about the 1 power and 0 power until you get into intermediate algebra. That's what we call those. And we're also going to write the degree. So we're going to write a comma, and then d is equal to the highest degree, or the degree is the highest power. So the highest power is obviously 4. X to the fourth power, so d equals 4. Again, that 4 came from here. Okay, so we did this in class number 2, I believe, somewhere at the very beginning of the course. So again, we did 3 things to that polynomial. We simplified by combining like terms, we wrote in descending order of powers, and we wrote the degree of the polynomial. Okay, so now it says add the following polynomials. So I'm going to add negative 5x cubed and 8x squared. Actually, you know what I'm going to do is I'm just going to get rid of these parentheses. The parentheses are just written so you know that you're adding one polynomial with another polynomial, but you don't really need the parentheses when you're adding polynomials. They're not really necessary, so I'm just going to get rid of those parentheses. And now we can add the like terms. Again, we want to add like terms. So negative 5 and 8 is 3. That's the x cubed terms. And then there is nothing to add the 3x squared term with. And I should probably mark these off as I go along. So we already added the yellow ones. And then we wrote the green one. Then we have negative x plus 9 is 8x. So that was the blue one. The blue ones that we added together, and then we can add the purple ones. Again, you don't have to use these colors. I'm just doing this so you can see what's going on. So we have 4 minus 1 is 3. So that is the solution. We added those polynomials. I'd prefer if you did this without colors. You don't really need the colors. I'm doing this to show you what's going on. So I'll probably stop using colors because it's kind of tedious having to use all these colors. So I'm just double checking that and it looks correct. So I'm going to stop using colors now just so we can go a little faster. Okay, so now we're going to add these polynomials, but like I said, you don't really need the parentheses when you're adding polynomials. They're just used to show you that you're adding one polynomial with another polynomial. So we can get rid of those parentheses, and we prefer to write in descending order of powers. You don't have to, but I'm going to write the x squared first, and 2x minus 3x is negative x, and negative 7 plus negative 3 is negative 10. So there you go. So that was number 2. Now let's go on to number 3. Now we're going to subtract the polynomials. Now, when you're subtracting, you don't really need these parentheses, but you certainly do need these parentheses. If you don't write parentheses there and you're trying to subtract polynomials, that's going to make things difficult. So at this point, when you're subtracting polynomials, I'm going to go ahead and get rid of those parentheses. When you're subtracting, what we're doing is we're subtracting this polynomial here. And what you're going to do is you're just going to change all of these signs. And we're going to take this purple sign here and we're going to change that to a positive. So this over here is a positive 3x squared. But we're going to change it to negative 3x squared. And this is a negative 7x. So we're going to change it to positive 7x. Whoops, I meant to put another parenthesis there. Parenthesis. And this is a negative 12, so we're going to change it to positive 12. So that's how you subtract a polynomial. whatever you're subtracting in yellow, you're going to take the subtraction sign, change it to a positive, and then you're just going to change every sign of the terms that you're subtracting. So that's just one way to think about it. So at this point, we're ready to go ahead and add these together. So we have 4x squared plus negative 3x squared, which is just x squared. And we have 2x plus 7x is 9x. And negative 6 plus 12, which is positive 6. So there we go. So let's try part B here. So again, we're subtracting. We can get rid of the parentheses. And by the way, you can do an intermediate step here if you want. You can change this just to negative 6 minus 3x squared. You don't have to write these parentheses. There's a lot of different ways to do this. I'm going to do that for now on because it just makes it easier. But again, we're getting rid of the parentheses. And so this is a negative x, right? You're going to change it to a positive x. And this purple negative is going to change to a positive. And this is a positive 2, so it's going to change to negative 2. So again, you just change the signs of all the terms that you're subtracting. And you change the subtraction sign to a positive. So now 10x cubed, we can't really do anything with that. 4x plus 1x is 5x. Negative 7 minus 2 is negative 9. So there you go. All right. So we're just getting warmed up here with these problems. So I'll try part A for this next problem, and you can try part B. So let's do part A first, though. So we're multiplying. So whenever you multiply, we're just using the distribution property. We're taking this negative 4x and we're multiplying it into the 3x squared. Then we're multiplying it into the 9x. Then we're multiplying it into the negative 4. It's called the distribution rule or the distributed property, whatever you want to call it. So negative 4x times 3x squared. First you do negative 4 times 3, which is negative 12. And x times x to the second power, you just add the power, so you get x to the third power. Now we're going to do negative 4x times 9x, which is negative 36 x squared. Negative 4x times negative 4 is positive 16x. And that's pretty much it for that problem. So as you can see, pretty easy. It's always good to double check your work. That looks good. So now, why don't you try part B? And when you come back, we'll do it together. All right, we're back. 6x times negative 3x cubed is negative 18x to the 6th power. 6x cubed times 4x squared is positive 24x to the 5th power. And 6x cubed times negative x, again we're using the distribution property, is, if my computer would speed up here, that would be negative 6x to the 4th. And then 6x cubed times 1 would just be 6x cubed, obviously. And I'm going to move this over. And let me make some more room here. So if you got that answer, good job. Now you might wonder, well, how come we don't add these terms together? Well, because they're not like terms. They all have different powers. So it's like adding apples and oranges and lemons and bananas. You can't add those together. They're not the same thing. You can add them together and call them a number of pieces of fruit, but you can't all add them together and say, well, it's this many, apples. because they're not all apples. They're apples, oranges, lemons, and bananas. Okay, so if you got that answer again, good job. Now let's divide polynomials. So this is all from class number 2, I believe, at the class entitled Polynomials. So we're going to divide this polynomial in yellow by this monomial in blue. And whenever you do that, you just take each term in the polynomial and divide it by the monomial. So you divide that one, and then you divide that one, and then you divide this one. So in case you forgot, let me show you what I mean. So we're going to divide negative 32x to the fourth by negative 8x squared. So negative 32 divided by negative 8 is positive 4. And x to the fourth over x squared, we learned how to do that in pre-algebra. You just subtract the powers when you're dividing. If you're multiplying x to the fourth times x to the second, then you add the powers, you get x to the sixth. But if you're dividing, then you just subtract the powers. So you get 4 minus 2 is 2, so we have x to the second power. So we just divided this first term by this monomial. Now we're going to divide the second term by the monomial. You just divide each term by negative 8x squared. Negative 16 divided by negative 8 is positive 2. And subtracting the powers, 3 minus 2 is 1. But we don't really use 1 power in this course. We'll use 1 power more in my intermediate algebra course. Now we're going to divide 56x squared by negative 8x squared. 56 divided by negative 8 is negative 7. And subtracting the powers, we actually get 0 power. But we learned in my pre-algebra course that these are just kind of, if you're dividing those, they just disappear. And again, you're going to learn in my intermediate algebra course that anything raised to the 0 power is just 1, but you don't have to worry about that now. So that is the answer. All right, so go ahead and try part B, and when you come back, we'll do it together. All right, we're back. 63 divided by 7 is 9. And 4 minus 1, there's 4 x's here and 1 x there, so 4 minus 1 is 3. 35 divided by 7 is 5. And there's 3 x's minus 1 x is 2 x's. And negative 56 divided by 7 is negative 8. And there's 2 x's here and 1 x, so 2 minus 1 is 1. So 1x just means put the x there, and we have the answer. So if you got that answer, good job. So it's been a while since we did these problems, so if you're a little rusty on this, that's okay. That's the whole point of this, is we're jump-starting your mind by doing practice problems. Because, again, you can't just take the test. If you're thinking to yourself, it's been a while since we did this, and I'm not really sure what we're doing, well, that feeling that you're having is the exact feeling that you would be having if you just try to take the test without studying for it. See, this forces you to kind of jumpstart your mind with this stuff. Okay, so now we're going to expand. This is multiplying two binomials. We have a binomial here, and we have a binomial here. Why are they called binomials? Because there's two terms in each one. There's 1, 2, and 1, 2 terms. And when we multiply binomials, we use that acronym FOIL. Remember FOIL? I'm going to write that up here. So F stands for first terms. We're going to multiply the first terms. X times 2x is 2x squared. Then we're going to multiply the outside terms. O stands for outside terms. X times negative 1 is negative x. And then we're going to multiply the inside terms. I stands for inside terms. Negative 4 times 2x is negative 8x. And then we're going to, L stands for last terms. Negative 4 times negative 1 is positive 4. Now, it's very important to understand that we have like terms here. These are terms that are like terms, so we can actually simplify that more. Negative x minus 8x is negative 9x. And that is the final answer. All right, so I want you to try part B, and when you come back, we'll do it together. All right, we're back. So 3x times 5x is 15x squared. So I multiplied the first terms, that's f of FOIL. Now I'm going to do O of FOIL, outside terms. 3x times negative 6 is negative 18x. Then I'm going to multiply the inside terms. 5 times 5x is 25x. And I'm going to multiply the last terms. 5 times negative 6 is negative 30. Now again, the inside terms are like terms, so we can combine those. So we have 15x squared and negative 18 plus 25, negative 18x plus 25x is positive 7x. And we're done. So if you got that answer, good job. If you didn't get that answer, that's okay. Now you know your brain has been refreshed there. And it's very important to understand that we're not doing a bunch of these problems. We don't have time to do a bunch of these problems. We're just doing, again, this is a practice test. This is an actual test, but it's a practice test. So you're getting an idea of the types of problems that are going to be on the test. And this is just to kind of jumpstart your mind again, but we can't do, maybe you need to do 10 of these problems. Well, go back to my classes, my previous classes, to the homework or to the classwork and do 10 of these problems if you need to do 10 of them. But we only have time to do maybe 3 of those problems, because this is a practice test. We're just reviewing things. We don't have time to review everything. Then we'd have to spend 10 hours doing this. You may need to practice these types of problems, but you don't need to practice these types of problems. Well, obviously it's a waste of time for you to do these problems. So practice these problems. You may need to practice these problems, but not these problems. Well, obviously it's a waste of time to practice these problems. So again, these are just things that are common sense. But you have to tell students again that you can tell students over and over again to study for the test. They're not going to do it. But you just need to figure out for yourself what you need to study. But when it comes to taking these practice exams, that's mandatory. Okay, so now we're going to, again, expand. Expand just means multiply, by the way. We're going to expand this multivariate expression here. So, again, using FOIL, 7a times 3a. Maybe I should bring down my FOIL over here. So 7a times 3a, that's 21a squared. And then we're going to do outside. 7a times b is 7ab. And inside, 2b times 3a is 6ab. And you might be wondering, well, should I write it as 6ab or should I write it as 6ba? Well, it doesn't matter. These are going to be like terms no matter what, because of the commutative rule of multiplication. And then we have L, which stands for last term. So 2b times b is 2b squared. Now, notice these terms in here. Again, it doesn't matter if you write it as 7ab or 7ba or 6ab or 6ba. It doesn't matter. They're like terms. You add them together. 7 plus 6 is 13. So we have 13ab. And we're just going to rewrite the first and last terms. So there you go. Okay, so now notice we have a binomial on this one, but this one is not a binomial, it's a trinomial. So FOIL doesn't really apply. So maybe I'll erase FOIL there. So for this one, what we're going to do is we're going to take this term and multiply it by every term in the other polynomial. And then we're going to take the other term in the binomial and multiply it by every term in this trinomial. So that's going to be a total of 6 terms. That's how you do these problems. So x times 6x squared is 6x cubed. And we're staying on the x. X times 3x is 3x squared. We're still staying on the x. X times -1 is negative x. Now we're done with the yellow x. We multiplied the yellow x by all these other yellow terms there. Now we're going to -2. We're going to multiply -2 times all these terms again. So -2 times 6x squared is -12x squared. And -2 times 3x is -6x. And don't worry, I'm going to move this over. And then -2 times -1 is +2. So notice again that we have 6 terms. I'm going to shrink this a little bit. So 1, I'll put a divider. 1, 2, 3, 4, 5, 6. Now we're going to combine like terms. There's only one third power term. And then we're going to add the x squared terms. 3 minus 12x is -9x squared. 3x squared minus 12x squared is -9x squared. Then we're going to add the -x and the -6x. And we get -7x. And the 2 just hangs out there. Alright, so that's how you do that type of problem when you're multiplying a binomial by any other, polynomial. And that same principle works. If you're multiplying a trinomial by another trinomial, you just take every term in the trinomial, the first trinomial, and multiply that term by every term in the other trinomial. And 4 terms, 5 terms, 6 terms, it doesn't matter. But I'm only going to give you a binomial times a trinomial. Or a binomial times a binomial. In that case, you use FOIL. So let's go down to number 8 here. So a lot of students get stuck on these types of problems because, it doesn't really look familiar. But what does it mean to raise something to the second power? Well, all that means is that you're taking that thing that you're raising to the second power, you're just taking it and multiplying it by itself. That's all raising to the second power means. It's like if you have x squared. X squared just means x times x, right? So if you have x plus 7 squared, that just means multiply x plus 7 times x plus 7. And parentheses means multiplication. So now, guess what we're going to use? We're multiplying a binomial by another binomial. Whenever you multiply binomials, you always use FOIL. So f, multiplying those, we get x squared. And then O, multiplying these, we get 7x. And then I, multiplying these, we get 7x again. And then O, multiplying these, we get 49. But of course, we have these inner terms that are like terms. So 7x plus 7x is 14x. And that's our final answer. All right. So part B is going to be a little bit more difficult because you have 2 variables, but I bet you could probably do part B. So why don't you go ahead and try part B. If you get stuck, that's okay, but attempt part B, and when you come back, we'll do it together. All right, we're back. So we have, again, raising to the second power just means you're taking whatever you're raising to the second power and you're multiplying it by itself. But we're multiplying 2 binomials, a binomial here and a binomial here, so we're going to use FOIL. So we're going to multiply the first terms. 2x times 2x is 4x squared. And then FOIL says multiply the outside terms. 2x times -y is -2xy. And you can write it as -2yx or -2xy, it doesn't matter. Then you're going to multiply the insides. -y times 2x is again -2xy. And you know what? I'm just going to write it as -2yx, just to show you that it doesn't matter the order when you're multiplying. These are still like terms. And now last terms, negative y times negative y is positive y squared. But again, these terms here are like terms, so we're going to add those yellow ones together. And our final answer is 4x squared. Negative 2 minus 2 is negative 4. And then plus y squared. So that yellow part simplified to this. And again, I don't really want you using colors on the test. I'm just using colors to help you remember how to do these. So if you got that answer, that's good. Good job. Okay, so now we're going to factor. Factoring is the opposite of multiplication. So factoring is really division. And these are the types of factoring that we did. We did GCF factoring and quadratic expression and difference of two squares and grouping and multivariate factoring and factoring of expressions of that form. And this here is a quadratic. How do I know it's a quadratic expression? Well, because we have a variable that's squared, we have a variable that is times some normal number, and we have a normal number with no variable. So whenever you have that situation, it's a quadratic expression. So we're going to write two sets of parentheses, and because we have x squared, we're going to write x and x. And this is just how you factor a quadratic. This is review again. If you're a little rusty on this, that's okay. So now we're going to ask what two numbers multiply to negative 15 and add up to negative 2. What are two numbers that multiply to negative 15 and they add up to negative 2? All right. So there's 1 times negative 15. That equals negative 15. There's also negative 1 times positive 15. That equals negative 15. The problem is if you add, remember they have to add up to negative 2. If you add 1 and negative 15, you get negative 14. You know, if you 1 plus negative 15 is negative 14. Or negative 1 plus positive 15 is positive 14. We don't want 14. Or negative 14. We don't want that. We want negative 2. So 15 times 1 didn't work. But what else can we do? Well, we can do 3 times negative 5, or we can do negative 3 times 5. In those cases, you get negative 15. But if you try, so that's where we, we're looking for negative 15 when we multiply those. But when you add those together, when you take 3 and add it to negative 5, you get negative 2. Bingo. There we go. If you add these two together, negative 3 and 5, then you get positive 2. We don't want positive 2. So the answer is 3 and negative 5. Those are the numbers we're looking for. So sorry if I'm going kind of slow here. If this is too easy for you, you can just go, fast forward the video, but I'm trying to review for students. So again, if you multiply these two numbers, you get negative 15, right? If you add these two numbers, then you get negative 2, right? That's just how you factor quadratic expressions. Now, so that's our answer basically. Now, if you foil this out like we did in the previous problems, guess what you're going to get? You're going to get this expression here. So we're just going backwards from what we were doing in the previous problems. Okay, so part B is a lot more difficult because notice we have a 4 there. This purple 4. In the previous problem, we didn't have a coefficient there except it's just assumed to be 1. So for this problem, we're going to have to write two sets of parentheses. It is a quadratic, because we have a variable squared, a variable, and then no variable. But this time, we're going to have to ask what two numbers multiply to 4. Now, it could be 2x and 2x. That you multiply those, you get 4x squared, right? But it could also be 4x and x. 4x times x is 4x squared. So we don't know which one it's going to be. Let's just try 4x and x. So now we're going to ask what two numbers multiply to negative 21. Well, there's 1 times 21, but there's also 3 times 7. And we don't know which one to make negative, so I'm just going to make the 7 negative. So in this problem, we had to do it differently. We cannot ask what two numbers multiply to negative 21 and add up to 8. We do want to ask what two numbers multiply to negative 21, but these two numbers, negative and 7, are never going to add up to 8. It doesn't work. Why? Because the 4. The 4 messes everything up. So all we're going to do is just ask what two numbers multiply to 4, and then we're going to ask what two numbers multiply to negative 21, and then we're going to do FOIL to see if it works. And if it doesn't work, we'll just try something else. We have to do trial and error. So F of FOIL, O of FOIL, I of FOIL, and L of FOIL. Add these two up, and you get negative 25x. That doesn't work. We want 8x, not negative 25x. Okay, so that doesn't work. But we can keep the 4 and the x, and let's just switch the 7 and the 3. So I'm going to put the 7 over here and the 3 over here. Now we're going to do FOIL again. F, O, I, L. So if we add these up, 7x and minus 12x, then we get negative 5x. We don't want negative 5x, we want 8x. So it didn't work. So what does that mean? Well, it probably means that we just need to use 2x and 2x rather than 4x and x. So again, 4x times x is 4x squared. We tried that, it didn't work. So now let's try 2x times 2x is 4x squared. Let's try that. So I'm pretty sure it's going to be 3 and 7, so I'm just going to use negative 3 and positive 7. And remember, this is taking a while, but it's only taking a while because I'm explaining it. It's going to go a lot faster with you when you're actually doing this, as long as you know what you're doing. If you study and you know how to do this, then this is going to be really easy. But if you don't study, then you're going to be, tripping on the exam. So now, I just put a 3 here and a 7 randomly. I'm not sure if that's going to work. I might have to put the 7 over here. So is it going to work? Well, let's see. So let's try, again, let's do F of FOIL, and O of FOIL, and I of FOIL, and L of FOIL. Now, if you combine these, 14x minus 6x, you get 8x. Bingo. So I just got lucky on that one. I just happened to choose the right combination. And if you got negative 8x, then all you'd have to do is just keep the 3 and the 7 in their place and just change the signs. You would have to just flip these signs. Okay, so again, I know that's kind of a long-winded answer or a long-winded explanation, but we're reviewing all this stuff. So now we're going to multivariate problems. And so there's three terms, and we have variables that are squared, so it's going to be a quadratic expression, but a multivariate quadratic. And we have a squared, so we're going to have a and a. And then we're simply going to ask, again, what two numbers multiply to 12 and add up to negative 8. Again, if there were a term in front of here, that would complicate things, but what two numbers multiply to 12 and add up to negative 8? So think about that. If you said negative 6 and negative 2, you're correct. But because we have b's, we have to add these b's here, you see. And you might think, well, how do you know that works? Well, if you FOIL it back out, you'll see why it works. All you have to do is FOIL this back out, and you'll see why it equals that expression up here. So that's all you have to do on that one. That's a multivariate problem. And So let's go on to part B here. Now, we're still factoring. Again, this is called factoring. We factored some problems down here, 2 problems down here. And now we're going to factor part B here. Now this is the difference of 2 squares. Again, we have GCF, quadratic, difference of 2 squares, grouping, multivariate, and factoring expressions of that form down there. So whenever you have, and by the way, I know this is the difference of 2 squares. There's 2 terms, number 1, and I have a variable squared here. So that's x to the 2nd power, and 4 is 2 to the 2nd power, you see. So it's the difference of 2 squares. I have a square here, and difference means subtraction. So whenever you have the difference of 2 squares, we learned in a previous class that you just write 2 sets of parentheses. You square root this term here to get x, and you square root this term. What number times itself is equal to 4? What number times itself is equal to 4? Well, there's only one number that works, 2. 2 times 2 is equal to 4. And because it's the difference of 2 squares, one sign is going to be positive and the other sign is going to be negative. That's it. You need to memorize how to do that, how to factor the difference of 2 squares. So before we go on to part number 11a, let's do 11b just so you can have a problem to practice for yourself. Now this problem we can't really do because it's not the difference of 2 squares. You're adding 2 terms together. That's not difference. But if we write the x squared first, then all of a sudden it becomes the difference of 2 squares. Again, we did problems like this previously. So now you can factor this problem just like you factored this problem up here. So why don't you go ahead and attempt that. Again, I know you're a little rusty on these problems. That's okay. But try part B down there, x squared minus 36, factor that, and when you come back, we'll do it together. All right, we're back. So we have x squared and 6 squared is 36. 36 is a perfect square. So what number times itself is equal to 36? Well, that's just 6. So we have a minus 6 and a plus 6. You always write minus and plus when you're factoring the difference of 2 squares. Again, this is all just review. This is giving you an idea of what you need to study for the test. And as we go through these problems, you might be thinking to yourself, well, I need more practice with that. If you need more practice, you can go back to my classes, look at the notes. You may have taken screenshots of all the notes. Go to the end of the class. If you go to the end of the class, or if you go into the description section of the video, you can click on that time code, and it takes you to the classwork, and also you can attempt the homework. Those are all practice problems you can do. So now here we have a square here and a square here. And we're subtracting, so that's the difference of 2 squares. So we square root this. What number times itself is equal to 9x squared? Well, that's just 3x times 3x is 9x squared. And what number times itself is equal to y squared? Well, that's just y. Y times y is y squared. And of course, when you're doing the difference of 2 squares, you just put a plus and a minus. Now, it doesn't matter if you put the minus here and the plus here. It doesn't make any difference. Again, it's the commutative rule of multiplication. Okay, so, number 12a would be a good one for you to try. Number 12a is going to be like these green problems that we did. So try number 12a, and when you come back, we'll do it together. All right, we're back. So we have a square here, and we have a square here. It doesn't look like a square, but if you write it as 10 squared, isn't it true that 10 times 10 is 100? So 10 squared is 100. So we have the difference of 2 squares. So all you do is just square root both of those. And so square root of x squared is x, and square root of 100 is 10. And of course, when you're doing difference of 2 squares, factoring difference of 2 squares, you always put a plus and a minus. So there you go. Okay, so for part B, Part B, again, is the difference of two squares. That's 4 squared minus y squared. Isn't it true that 4 squared is 16? 4 to the second power, that's just 4 times 4. That's 16. So, because it's the difference of two squares, we're just going to do two sets of parentheses. Square what number times itself is 16? That's just 4. And what number times itself is y squared? That's just y. And of course we put plus and minus. And there you go. Okay, so now we have an interesting problem here because, again, it doesn't look like the difference of two squares. You're adding them together, these terms. But if you flip them around, and that's the commutative rule of addition, you know, a plus b is the same thing as b plus a. You can switch them around. It doesn't make any difference. So now, again, it's the difference of two squares. How do I know 81 is a square? Well, because 9 times 9 is 81. It's a perfect square. So we can write that as 9 squared minus x squared. It's the difference of two squares. So square root of 81 is just 9. And then we put our x's and make sure we put plus or minus. What number times itself is equal to 81? That's just 9. Okay, so why don't you go ahead and try part B? If you get stuck, that's okay. Part B is a little bit different than part A, but remember, you're just going to square root 49 and square root this here and put a plus or minus. So try part B, and when you come back, we'll do it together. All right, we're back. So we have difference of two squares, so we're going to, what number times itself is equal to 49? Well, that's just 7. What number times itself is equal to 64? Well, that's just 8. But because there's a b squared there, it's going to be 8b. And of course, with difference of two squares, you have a plus and you have a minus. So if you got that answer, that's good. Good job. Now, when you FOIL this out, the inner terms are going to be exactly the same. The only difference is they're going to have different signs. So when you add them together, they disappear. That's why, you know, when you FOIL this out, you get to this, is because the F, or the O and the I term, they just cancel each other out, and you're left with FL. This is F and L, you see. That's how difference of two squares works. Two squares. Now, if that just makes you nervous thinking about all that logic, all you have to know is how to do the problem. You don't have to even understand all the logic of it. Mathematicians don't think about the logic when they're doing this. They just know it works. They come up with algorithms, use the algorithms, and they try to make things as efficient as possible, so you can just use a quick algorithm. So even mathematicians don't really think about the logic of it. They just use the algorithm because they know it works. Okay, so now we have the factoring of this form, which is kind of like quadratic factoring. It's pretty much the same type of thing, depending on how you think about it. But it's just going to be two sets of parentheses, and because it's x to the fourth, we're going to have to do x squareds. X squared times x squared is x to the fourth. And just like we do with quadratics, because there's no coefficient here, we're going to ask what two numbers multiply to -4 and add up to +3. What two numbers multiply to -4 and add up to +3? Think about that. The answer is going to be +4 and -1. 4 times -1 is -4, and 4 plus -1 is +3. So we factored correctly. So you might be tempted to rectangle that and say we're done. Well, actually we're not done, because this here is the difference of two squares, so we can factor that even more. So we have x squared, and that's the same thing as 1 squared. 1 squared is equal to 1, so we put a plus and minus. If you ask what number times itself is equal to 1, then that's just 1. So there you go. And you might think, well, what about the x squared plus 4? That's the difference of two squares. Well, no, that's the sum of two squares. It's not the difference of two squares. See, here you have a minus. Also, I should tell you that sometimes you're going to have the difference of a square and then a number that's not necessarily a square. You could write this number as a square, but that would get kind of complicated, so we don't really factor these. It has to be a perfect square. X squared minus 15 is not easily factorable, but if it's x squared minus, say, 81, then that's a perfect square. 9 times 9. Or if it's x squared minus 4, that's a perfect square because it's 2 times 2. So it has to be a perfect square in order for us to be able to easily factor it. These are all things that we learned in previous classes, and you might be thinking, well, this is giving me a headache. I don't like this. I don't remember doing this. Well, you did it. You just did it a couple weeks ago. And it's better to have a headache now than to have a headache when you're taking the test. So that's why we're doing this. We're not doing comprehensive review here. We're not going to review every single thing. That would take too long, and it's unnecessary for you because you don't need to review every single thing in the entire class. You just need to, review whatever you need to work on. But I don't know what you need to work on. Only you can tell. But again, this test is forcing you to do a little bit of studying to jumpstart your mind, and it's also showing you what the tests are going to be like. So again, we have an expression that's kind of like a quadratic, but it has x to the 4th. So we're going to have x squared and x squared. And we're going to ask what two numbers multiply to 64 and add up to negative 20. Two numbers that multiply to 64 and add up to negative 20. That's not easy. Those are kind of big numbers. But see if you can do that. See if you can figure that out. That's kind of you might want to use a calculator. It's kind of a big numbers. I'm not going to give you big numbers like that on the actual test. But see if you can do that. Figure out what two numbers multiply to 64. And I'm going to give you a hint. The two numbers that are going to multiply together have to be negative. Because a negative times a negative is positive. But a negative plus a negative is a negative. So two negative numbers that multiply to 64 and add up to negative 20. See if you can do that. Stop the video. All right, we're back. So that was kind of a hard one, but it's going to be negative 16 and negative 4. 4 times 16 is 64. I know that was kind of a dirty trick to give you such a hard problem like that, but the reason I did that is because now we have a difference of two squares here, and we have a difference of two squares here. So we're going to actually continue to factor those. So negative 16 times negative 4 is positive 64, and negative 16 plus negative 4 is negative 20. But now we're going to factor the yellow expression, difference of two squares. What times itself is equal to 4? Well, that's going to be 2. Remember, always put a plus and minus. Then we're going to factor the blue expression. Whoops. What two numbers multiplied or what number multiplied by itself is equal to 16? Well, that's just going to be 4, so we put a plus and minus again. And that's it. That's the answer. So in that problem, we factored an expression of this form, but then we had to use the difference of two squares to factor it completely. You may get into trouble on this test. You may factor, but you won't factor completely on some of these problems. You're not going to get full credit unless you factor completely. So now we have these weird problems with fourth power again, but now we have a coefficient here. That coefficient messes everything up. Our two numbers are going to, and maybe I should write two sets of parentheses first. Our two numbers are going to multiply to negative 3. They're always going to multiply to this number. But because of this term here, this coefficient, the two numbers are not going to add up to 7, so that complicates things. So first we have to ask what two numbers multiply to 6. Well, we could do 6x squared and 6x squared and x squared. They multiply to 6x to the 4th. But we could also do 2x squared and 3x squared. So which one should we do? Well, I don't know. Let's just try 2x squared and 3x squared. See if that works. So what two numbers multiply to negative 3? Well, I'm going to try negative 3 and positive 1. I don't know where to put the 3 and the 1, but let's just try it there and see what happens. So now we're going to FOIL. F is 2x squared times 3x squared, 6x to the fourth. O is 2x squared times 1, which is 2x squared. I is negative 3 times 3x squared, which is negative 9x squared. And negative 3 times 1 is negative 3. So the question is, did it work? Well, 2x squared minus 9x squared, those are like terms, and we get negative 7x squared. So as you can see, this expression is exactly the same as this expression, except we have a plus 7, and down here we have a negative 7. So what that means is all we have to do is go back to here and change this negative to a positive, and change the positive to a negative. And then we're done at that point. So all this stuff down here was just to check, FOIL that, and see if it equals this. Now you might say, well, this is the difference of two squares. Well, 1 is a perfect square. 1 squared is 1, but 3 is not a perfect square, so we can just leave that. We don't have to factor that anymore. So that's the answer. All right, so again, this is just reviewing, showing you what the test is going to be like. Okay, so now part B. Now, notice that there are, we're going to, again, this is all factoring. The directions down here are to factor completely. We're still doing all these problems where we're factoring completely. So this problem up here is the first problem where we see that there are 4 terms. Whenever you see 4 terms and you're told to factor, it's probably going to be a factoring by grouping problem. So we're going to take this group here and we're going to factor out the GCF. We're going to factor out that GCF. What numbers are common, the greatest common factor of those two numbers? Well, if 10 goes into this number and 10 goes into this number, so I'm going to pull out a 10. We also have x squared and x cubed, so remember, choose the smallest power and factor that out. So x squared is common to both those. So now I'm going to ask 10x squared times what is equal to 10x cubed? 10x squared times what is equal to 10x cubed? Well, if I just multiply by x, 10x squared times x, isn't that 10x cubed? There you go. So 10x squared times what is equal to negative 80x squared? 10x squared times what is equal to negative 80x squared? Well, if you said negative 8, you're correct. So let me show you again why this works. If you distribute, and again, all we're doing is using these terms here. We're ignoring these blue terms over here. We don't care about those right now. So to understand why that works, if you multiply 10x squared back to x, you get 10x cubed using the distributive property, and 10x squared back to negative 8. Multiplying those, you get negative 80x squared. So that's why that works. So now we're going to go to the second group. Now we're going to see what's the biggest number that goes into 3x and 24. Well, it's going to be 3. I'm going to pull out a 3, factor out a 3. 3 times what is equal to 3x? 3 times what is equal to 3x? Well, obviously that'll just be x. 3 times x is 3x. 3 times what is equal to negative 24? 3 times what number is equal to negative 24? Well, that's just going to be negative 8. So we factored that blue part to this expression here. So that's why it's called factoring by grouping, because again, we're doing the yellow part separately and the blue part separately. We have groups, the yellow group and the blue group. Okay, so now I want you to notice that we have, maybe I'll try to color code this, we have this x minus 8 here, but we also have an x minus 8 right there. Doesn't look like the coloring is working very well. So we have an x minus 8 on both of these terms, the yellow term and the blue term. So what we're going to do is we're going to factor out that x minus 8 out of the whole thing. And we're going to be left with 10x squared plus 3x. And we're done. So again, if you take this x minus 8 and multiply the whole thing into 10x squared, then don't you get 10x squared times x minus 8? The terms are reversed, but it doesn't matter because the commutative rule of multiplication. If you take x minus 8 and multiply the whole thing times 3, then you get this blue thing. So all we're doing is just taking the x minus 8 and the x minus 8 and factoring them out into this x minus 8 here. So again, that's just review. That's factoring by grouping. So if you want to, you can try number 16. I think number 16, actually, why don't you try part B of 16, try that one, see how it works, and then we'll do part A. Again, if you get stuck, that's okay, but part B is going to be factoring by grouping just like part B in number 15. So go ahead and attempt part B down here, and when you come back, we'll do it together. All right, we're back. So I've got a green part here that I'm going to factor out the greatest common factor, which is going to be b to the 4th. If I multiply this back, don't I get b to the 5th plus 2b to the 4th? So I factored that, I have GCF out of that. And I'm going to factor a negative 8 out of these terms over here. So I factor a negative 8 out of those. So isn't it true that negative 8 times b is negative 8b, and negative 8 times 2 is negative 16? Isn't that true? Okay, so now, do you see how I have b plus 2 and b plus 2? These two factors here, the b plus 2's, they should be the same. If they're not the same, just like the x minus 8's up here were the same, if they're not the same, that means you did something wrong. Okay, so we're going to factor that b plus 2 out of both of those, and then we're left with b to the 4th minus 8. Now you might say, well, b to the 4th minus 8, that's a difference of 2 squares, but 8 is not a perfect square, so you don't have to worry about that. So if you got that answer, good job. If you got stuck, that's okay. Again, it's been a while since we did these problems. So if you want to, you can try number 16, 16a, that is. If you get stuck, that's okay, but go ahead and attempt number 16a. All right, we're back. So I'm going to factor out x squared in the first two terms. Then I'm going to do something very strange. I'm going to factor out 1. I'm going to use the negative 1 rule. I'm going to factor out negative 1. Isn't it true that negative 1 times x is negative x? Isn't that true? Negative 1 times x is negative x. Isn't it true that negative 1 times negative 3 is positive x? Then this is correct. All I did was just factor out a negative 1 from these two terms. So again, I have these terms here, and I have these terms here. Okay, so now I'm going to factor out an x minus 3 because x minus 3 is common to both those, and that's how I know I did it correctly. So then I'm left with an x squared and a negative 1, which I put down here. Problem is x squared minus 1 is the difference of two squares. So I need to continue to factor that. So x squared minus 1, that would just be x minus 1 and x plus 1. So there you go. If you got that answer, good job. Okay, so now why don't you try number 17, and when you come back, we'll do it together. All right, we're back. We're going to factor out x squared in the first two terms. And then we're going to factor out, negative 2 on these other terms. Isn't it true that if you multiply negative 2 times 7x, you get negative 14x? And if you multiply negative 2 times negative 3, you get positive 6. So that's how I know I did that correctly. So now, you see these 7x minus 3's, they're going to come out. Factor those out, so we get 7x minus 3, and then the x squared and the minus 2, they're going to stay there, so we have x squared minus 2. And we're going to rectangle that. And this is not the difference of two squares because 2 is not a perfect square. Perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, so on and so forth. Okay, so for number 18, we're starting to do combined types of factoring. We did a little bit of combined types of factoring. Sometimes we do a factoring by grouping problem and we have a difference of two squares. But here we're going to do a GCF problem. See if you can find the GCF, the greatest common factor, and pull it out of these two terms. Go ahead and do that. And when you come back, we'll try it together. All right, we're back. So they both have x's. So we're going to pull out the smallest number of x's in both terms. So that's just going to be x. So I'm going to pull out x. And 3 is a factor of 75 and 3. So I'm going to pull out 3. So that's going to be the greatest common factor, the GCF. 3x times what is equal to 3x squared, 3x cubed? The answer is x squared. 3x times what is equal to negative 75x? Well, that's just going to be negative 25. All right, so I pulled out a GCF from these terms up here. Problem is now we have difference of two squares. See, so we did a GCF problem, but now we have to factor the difference of two squares. 25 is a perfect square, and we're subtracting, so that's a difference of two squares. What number times itself is equal to 25? That's obviously 5. So if you got that answer, good job. That was combined types of factoring because you're combining a GCF problem with a difference of two squares problem. Okay, so number 19, we also have another combined type of factoring problem. And so maybe you should try number 19. We haven't done a problem exactly like that, but maybe you can attempt it and see how you do. Again, if you get stuck, that's okay, but try number 19. When you come back, we'll do it together. First, you're going to pull out a GCF, just like we did in problem number 18. You're going to pull out that GCF. Then you're going to be left with a quadratic expression. And that means you're going to have to write two sets of parentheses and then ask what two numbers multiply to the third number and add up to the middle number. So try number 19. I know that's a lot to think about, but try number 19. When you come back, we'll do it together. All right, we're back. I'm going to pull out or factor out a 9 and an x. That's common to all these numbers, all these terms. So 9x times what is equal to 9x cubed? That's going to be x squared. 9x times x squared is 9x cubed. 9x times what is equal to 18x squared? Well, that's going to be 2x. 9x times 2x is 18x squared. 9x times what is equal to 9x? That's one that kind of confuses students. 9x times what is equal to 9x? Well, that's just 1. A lot of times students don't write anything here, or they write 0. That's not correct, because 9x times 0 would just be 0. It wouldn't be 9x. Remember, anything times 0 is just 0. Okay, so we factored out our yellow GCF, right? And now you see we have a quadratic. So what two numbers? Well, first of all, because it's a quadratic, we're going to write two sets of parentheses. And we're going to ask what two numbers multiply to 1 and add up to 2. What two numbers multiply to 1 and add up to 2? Well, there's only one number that would work. It's 1. 1 times 1 is 1, and 1 plus 1 is 2. So that is the completely factored form. If you did that correctly, good job. If you didn't, that's okay. Again, we're just jump-starting your mind to prepare for the test. All right, so now we have another GCF problem. See if you can factor out a greatest common factor on number 20. And then once you do that, I believe you're going to have the difference of two squares, but it's going to be x to the 4th power. When you factor x to the 4th power and a difference of two squares, it's going to become x squared times x squared. If you get stuck, that's okay, but try number 20. When you come back, we'll do it together. All right, we're back. So these numbers are kind of big. Let's see here. I think it's going to be 6. And x to the 4th power, those are the biggest. So they both have x's, so we can factor out x's, and we're looking for the smallest power. That's what you can factor out of all those. 6 times 4, 6x to the 4th times 4x to the 4th. If you multiply these terms, you get 24x to the 8th, right? And if you multiply 6x to the 4th times some number here, you get negative 54x to the 4th. But what is that number? Well, 6 times 9, negative 9, is negative 54. And I think that's it. 6x to the 4th times negative 9 is negative 54x to the 4th. So there you go. Okay, so we factored out the GCF, greatest common factor, or greatest common monomial, whatever you want to call it. But now we have the difference of two squares, because I know this is a perfect square, and this is a perfect square, and this is a perfect square also. And we're subtracting them, so it's a difference of two squares. So now I have 6x to the 4th, and I'm going to write two sets of parentheses. That's just what you always do when you have difference of two squares. And we're going to square root this. What number times itself is equal to 4x to the 4th? Well, that's just going to be 2x squared and 2x squared. Notice I asked what two numbers multiply to 4, and I also asked what two expressions multiply to x to the 4th. And the numbers have to be the same. So what number times itself is equal to 9? Well, that's just going to be 3. And again, with difference of two squares, it's always plus and minus. So there you go. All right. So if you got that one right, good job. But if you didn't get it right, that's okay. There's quite a lot of problems that we're doing here that you haven't done in a while, in a couple weeks probably. Or maybe you did it in the last class, I forget. Okay, so now we're going to factor out the GCF. Again, we're just factoring these expressions. That's what we're doing. We've been factoring the last 10, 12 problems. So these numbers are kind of big. I'm not going to give you big numbers like this on the test. I think I might break out my calculator because these numbers are so big. 312 divided by 3 equals 104. So I'm going to factor out negative 3. And that becomes 104. This is actually supposed to be x to the 2nd power. Sorry about that. X to the 2nd power. And 1200 divided by 3, that's going to be, I believe, 400. And actually, that should be minus 104. Now, to check to see if that's correct, we just multiply negative 3 back into all these terms, and using your calculator, you can see that works. So let's see here. Just double checking, making sure that works. All right, so now we have what appears to be some form of a quadratic. So we're going to write x squared and x squared, but it's the fourth and second power quadratics. What two numbers multiply to 400 and add up to negative 104? That seems like it's going to be a pretty difficult thing. But again, I'm not going to give you a problem that's this hard on the test because that's kind of a nasty problem, but it's going to be negative 4 and 100. Sorry about that. That's kind of a difficult problem. Again, I'm not going to give you ones that are that difficult on the test. So the reason I did that problem is because, again, we have difference 2 squares here and we have difference 2 squares here. So I'm going to factor x squared minus 4. I'm going to factor x squared minus 100. So there you go. So that is the final answer. All right, so I'm going to shrink this a little bit to make some more room. And maybe put a divider because we're kind of running out of room here. Okay, so now we have multiple variables. Don't be afraid to put dividers to organize your work. But we're always going to start out with the GCF on these types of problems. So they both have A's and they both have B's. I have a B here and I have one A there. So I'm going to factor out AB. And I'm going to also factor out, let's see, what's the biggest number that goes into both these? I think it's going to be 2. So 2ab times what is equal to 32a cubed b? That's going to be 16a squared. Multiply these two, and you get 32a cubed b. 2 times what is equal to 18? Negative 18, that's going to be negative 9. And, you can do it separately if you want. A times what is equal to a. B times what is equal to b cubed. Well, that's just going to be b squared. Wait a second. Sorry about that. A times what is equal to a. Well, there is no a. You don't need an a there. But you do need a b squared. Sorry about that. I hope I'm not confusing you. So 2ab times this is equal to negative 18ab cubed. Negative 18ab cubed. So now you're left with difference 2 squares. B squared is a perfect square, a squared is a perfect square, and 16 is a perfect square, and 9 is a perfect square. So when you have a difference 2 squares, we have to write 2 sets of parentheses, and we know this is going to be our final answer probably. And what number times itself is equal to 16a squared? Well, that's just going to be 4a and 4a. What number times itself is equal to 9b squared? Well, that's just going to be 3b. So remember, you always put a plus and a minus with difference 2 squares. Okay, so again, we don't have time to go through hundreds and hundreds of these problems. I'm just showing you what the practice or what the test is going to look like. And we're just reviewing, just getting an idea of what's going to be on the test and jump-starting your mind from the things that we did in the past 2-3 weeks. Okay, so again, we're going to pull out a GCF. Every one of these terms has x's in them, and the smallest number of x's is just 1x. So I'm going to pull out 1x, and you see I have a negative on the first term. We don't like that, so we're going to pull out a negative also. And I think that 3 is common. 3 goes into all those numbers. So I think negative 3x is going to be the GCF. So negative 3x times what is equal to negative 45x cubed, and it looks like it's just going to be 15x squared. Again, I know that's kind of a big number. Sorry about that. I'm not going to give you those big numbers on the test. Negative 3x times what is equal to 42x squared y? Well, that's just going, 3 times what is equal to 42? I think that's going to be 14. Again, I know that's kind of a big number. And x times x is x squared, and of course we have a y. And negative 3 times what is equal to negative 9? That's just going to be positive 3. And we already have an x, so we don't need an x out here. We're multiplying this in. But we do need a y squared. So again, in order to see why that works, you just multiply back. Okay. So now we have a multivariate quadratic expression, so it's going to be two sets of parentheses. What two numbers multiply to 15? Well, I'm just going to try 3 and 5. What two numbers multiply to 3? I'm just going to try 1 and 3. So I just realized these both happen to be negative. Negative times a negative is a positive, but a negative plus a negative is a negative. So now let's do FOIL. 3x times 5x is 15x squared. 3x times negative 3y is negative 9xy. Negative y times 5x is negative 5xy. And negative y times negative 3y is positive 3y squared. Add these two numbers together and you get negative 14xy. So I got lucky on that one. Just happened to be the right combination. If I put this 3 over here, then I wouldn't have got the right answer, but that's okay. You could just you just do trial and error. Whenever there's a coefficient here, you just do trial and error, see what works. Use FOIL and see if the O and the I term add up to whatever this middle term is. Okay, so I've got two more problems. So let's try this problem here. Why don't you try this problem? It's kind of a different problem. What do you think this is going to be? Is this going to be quadratic, difference of two squares, GCF, grouping, multivariate factoring, factoring of the form ax to the 4 plus bx squared plus c? What is this? Well, there's 4 terms. Whenever you're asked to factor and there's 4 terms, it's probably going to be factoring by grouping. So if you get stuck, that's okay, but go ahead and try 24. You're going to factor out a GCF from both of these terms, the greatest common monomial, but there's going to be something kind of weird on this one. So the factor for this one is actually just going to be 1. So if you get stuck, that's okay, but try 24. When you come back, we'll do it together. Okay, so I'm going to take these first two terms, this group here, and factor out a GCF, which is going to be x squared. Actually, it's going to be negative x squared. You almost always want a positive first term. So negative x squared times what is equal to negative 2x cubed? That's going to be 2x. Negative x squared times what is equal to 3x squared? Well, that's going to be negative 3. Again, to see why that works, you just distribute back and you get the yellow expression. So now we're going to use this other blue group here, but the problem is there's nothing really to factor out of these. There's nothing common in both these except 1. So what you can do is you can put parentheses and just write a 1 there. So now you see that we have these purple 2x minus 3's that are the same. So I'm going to factor out those purple 2x minus 3's. And you're left with negative x squared plus 1. See the purple 1 and the negative x squared? That's what's left when you factor out the 2x minus 3 from both those terms. I know that's a lot to think about, but this is all review. Now, we cannot factor this green negative x squared plus 1 because it's not the difference of two squares. It's the sum of two squares. So we have to flip it around, and now it becomes the difference of two squares. So now you just need two sets of parentheses. What number times itself is equal to 1? what number times itself is equal to x squared. That's just x and x, and put your plus and minus, and you are done. So there we go. So I know this seems like a lot, but we have done this in the last 2-3 weeks. This is just review. There's tons of problems in your class notes, the classwork that we did that you can access easily by going in the description section of the video, clicking on the number codes. There's also your homework that you did that you can look at all the answers, and you have plenty of practice problems. But again, this is just getting familiar with the test and jump-starting your mind with these problems again, because some of these problems you haven't done for a couple weeks, possibly. All right, so last problem of this test is number 25. There's 25 problems in this test. There's always 25 problems in all my tests, pretty much. And each problem is worth 4 points for a total of 100 points. Okay, so we're going to factor out a GCF, which it looks like it's going to be 2. 2 goes into all those numbers. That's the biggest number that goes into all those numbers. And you see that there's a's in every one of these terms, but the lowest number of a's is a squared, so I'm going to factor out a squared, and the lowest number of b's is b cubed, so that's going to be our GCF. And 2 times 6 is 12, and a squared times a squared is a to the 4th, and b cubed times nothing is b cubed. 2 times -1 is -2, but I don't have to write the 1. A squared times a is a cubed, and b cubed times b is b to the 4th. 2 times -5 is -10. A squared times nothing is a squared, and b cubed times b squared is b to the 5th power. So again, I just pulled out a yellow GCF, greatest common monomial, greatest common factor, whatever you want to call it. So now I have this term here, and that kind of looks like a multivariate quadratic. So what two numbers multiply to 6 and add up, or what two numbers multiply to 6? I'm just going to try 3a and 2a. What two numbers multiply to -5? Well, I'm just going to try, there's only one option, 5 and 1, really. So -5b times b is -5b squared. And 3a times 2a is 6a squared. Okay, so the problem is, I don't know if that worked. We're going to have to test that. So, FOIL, 3a times 2a is 6a squared. 3a times b is 3ab. -5b times 2a is -10ba. Or ab, it doesn't really matter. -5b times b is -5b squared. So again, notice that the outside terms, they always work if you set it up properly, but we need to know if the inside terms add up to -1ab. Problem is they don't. You get -7ab, so that didn't work. But before you give up on that, what you can do is you can take this 5 and switch it and move it over here, and put the b over there. So now let's try FOIL. F O I L. Combine these terms and you get 13ab. Still didn't work. So what does that mean? Well, it means that it looks like 3 and 2 are not going to work. Instead of 3 times 2 is 6, we're going to do 6 times 1 is 6. Let's try that one. Again, this is just trial and error. It's perfectly fine to do trial and error here. Whenever you have a coefficient here, you're going to have to do trial and error. Okay, so now we do FOIL again on this yellow part to see if we factored correctly, and we get 6a squared f O, and I can already tell that's not going to work, so might as well not even try that. It's too big. So I'm just going to try putting the 5 over here, and the b over here, see if that works. So again, now we're going to FOIL this yellow part again to see if it equals this expression. F O I L. So now if you add these up, you get positive, 6 minus 5 is positive 1ab. We're almost there. We want positive 1ab. This is negative 1ab. So we almost made it. We got the right number, we just have the wrong sign. So all we have to do is just change this sign to a positive and change this sign to a negative. And there you go. So that is the final answer. And so that was the practice test, 25 problems. Now again, you might be a little rusty on some of that stuff, but that's okay. Let's go ahead and you can take screenshots of all the work that we did to help you study for the test. And you can go back over these problems, covering the answers, and see if you can do them on your own. But this is not the only resource that you're going to have. Again, you can take screenshots of all those if you want to have those for your notes to study for the test. The other resource that you're going to have is another practice test. So this is going to be your homework. Notice it says version 2. We just did version 1 of this test. So to take screenshot number 1, this is mandatory for your homework. Screenshot number 2. Screenshot number 3. You don't get a choice on doing this homework. Screenshot number 4. This is you must do the homework, and don't leave before you get the answers. You're going to need to check. You need to make sure that all your answers are correct. It's not enough just to attempt the homework. You have to do it correctly. So get a screenshot of these answers and the last page of the answers. So make sure you do that homework completely, correctly, neatly, and keep it in order in your binder. And this practice test that you're going to do for homework is going to ensure that you at least do a little bit of studying. And like I said, you can use the practice test that we just went over to help you also. So get that practice test done. Do not watch the next video and do the actual test in the next video unless you know how to do every single one of those problems. So that said, I'll look forward to seeing you in the next class when we take the actual exam, test number 1 of this course.